Hello my dear students. Today we are going to discuss one of the important topic from the grade 12, that is of vector algebra. Okay, so without wasting our time, let's move ahead. Let's start with the basic concept from the topic. Let's move ahead. Let's see the topic vector algebra. So what are the important concepts from this topic? Let's see. So to go through this topic, to solve the example on this topic, some basic concepts, basic definitions are there, so we'll discuss them one by one. So here the first term related to this is the vector. So what is a vector? Vector is simply a quantity that has magnitude as well as the direction, right? So that quantity is known as a vector. So every vector should be defined with the help of magnitude as well as direction. So these two terms we need to define a vector. Okay, so any quantity having its magnitude along with its direction is said to be a vector. So what are the example from the vector? We can say like the distance of a line segment, right? Distance of a line segment or just a line segment, these are the vectors, right? Because distance, it means it has some direction from one point to other point, right? And it has some definite length, right? So that is nothing but the vector quantity, right? So while defining the vector quantity, what are the notations to be used here? So as if you see the diagram given here if you see the these are the three diagrams given, 1, 2 and 3. So in which in the first and second they are the lines given in two different directions, right? And in the third diagram it is given the 2 points given on the same line, and it is denoted as the vector AB bar, and it simply can also be denoted as A bar. So the bar is nothing but the one-sided arrow given on the same letter, right? So here we denote that vector as a vector AB bar or simply A bar, and we read it as vector AB bar or a vector A bar only. So if you observe here, there are 2 points A and B, and it's the point A from where the vector AB bar starts is known as the initial point, and the point B where it ends is known as the terminal point. So vector has 2 points, point A and B, the initial point and terminal point. So from where it starts is known as the initial point, and where it ends is known as a terminal point. Right? So these are the two important points here. Along with that, as it is the vector AB bar, the distance between the initial and terminal points of a vector is nothing but its length, or here it is known as the magnitude of that vector, right? The distance between these 2 points on this segment, on this line. So we can have a segment AB and we can have its distance, we can measure its distance, right? So it has a direction from A to B and it has some length AB, right? So this quantity is defined with the help of direction as well as magnitude. I hope it is clear now. So this is nothing but a vector. Vector needs the two terms known as magnitude and direction, without which the vector cannot be defined. If any one of these two are the term is not defined with these 2 points, that term will not be a vector quantity, right? So the magnitude of a vector is denoted by this notation, that is a mod sign for a vector AB bar, or simply mod of vector AB bar, or simply you can denote it as A only. So that A itself indicates the length of the segment AB, length of that vector AB bar, right? So that arrow indicates the direction, and it is from A to B here in this example. Now let's move ahead, and as we know the length is never negative, so that magnitude will never be negative, right? It is always positive. Now let's move ahead. the next term for the vector related to the vector is known as a position vector, right? Since we know, we have studied in grade 11 also the three-dimensional right-handed rectangular coordinate system that we have seen. So for that, using that concept, so consider point P in the space having the coordinates x, y, z with respect to the origin, that is O0, 0, 0. If you observe this diagram given here, this is a point P, x, y, z in the space. So in space means it has three dimensions, that is it has three coordinates. So it has three coordinates, x, y and z coordinates, right? So it is known as a space, three-dimensional space. So the point P is in a space, as we know the coordinate system in which we have only two dimensions, right? That x and y coordinates only. So that is called a coordinate system only. It has only two dimensions, but in space it has three dimensions. That is in this coordinate system we have three axes, three coordinate axes, x, y and z. So that part we already discussed in the grade 11, right? So now, as we are discussing about the position vector of a point in the space, position vector of a vector, here we have, so a point P in the space having the coordinate x, y, z with respect to the origin, it is OP bar only. So the vector OP bar having O and P as its initial and terminal points respectively is known as the position vector of the point P with respect to the origin, right? So that already we have learned the distance formula in the space, in three-dimensional space. The magnitude of vector OP bar will be given by finding its magnitude. So that is a distance formula between 2 points in 3D space is given by root of, if we have 2 points x1 y1, x1 y1 z1, x2 y2 z2, then the distance between those 2 points in the space is given by root of x1 minus x2 the whole square plus y1 minus y2 the whole square plus z1 minus z2 the whole square. But here we have since it is the distance between the point P, x, y, z and the origin 0, 0, 0. So x1 minus x2 means it will give us x minus 0 means x only. Similarly for y minus 0 it will be y and z minus 0 will be z. So it is written directly as root of x square plus y square plus z square, right? So this is the position vector of point P with reference to origin. So in the same way we can find the position vector of the any point with respect to some other point also, that we will discuss in time being after some time. Okay, so in practice the position vectors of the points A, B, C with reference to the origin, they are denoted by the vectors simply A bar, B bar, C bar and so on as shown in the diagram here. These are the points A, B, C, so their position vectors will be simply denoted by A bar, B bar and C bar only. Now let's move ahead with the next important concept known as the direction cosines. So what are the direction cosines? Let's see here. So consider the position vector OP bar of a point P, x, y, z as shown in this diagram. You have seen the diagram given here. The point P is here, x, y, z. The point P, x, y, z in a space, right? Now the angles alpha, beta, gamma made by the vector r bar with respect to or with the positive directions of x, y and z axis respectively, they are known as the direction angles. So if you observe the diagram here, you come to know that this is the angle made by this r bar with x axis, then this one is the angle made by this r bar with y axis, and this one is the angle made by this same vector r bar with z axis, right? So these angles are known as the direction angles, and simply the cosine values of these angles, that is cos alpha, cos beta and cos gamma, they are known as the direction cosines of the vector r bar, and they are generally denoted by the letters L, M and N respectively. Okay, so I hope it is clear. I will repeat it once again. The direction cosine, they are nothing but the cosines of the angles made by a vector r bar with the positive directions of x, y and z axis, right? So it is simply a direction cosine, and they are generally denoted by the letters L, M and N. Now from this you can just observe the triangle drawn here, triangle OAP. That triangle OAP, if you observe the diagram here, this one is the point O, this one is the point P, and this one is the point A on x-axis. So that is nothing but the diagram shown in the 3 dimensions, but actually this will be of this kind. That is a triangle OAP, in which the angle A will be 90-degree angle. As we know, the distance of any point from a line will be simply a perpendicular distance, right? So this OA is nothing but the perpendicular drawn from the point P on x-axis. That gives us that I've read this concept why this PA is perpendicular here. I hope it is clear. So we can say the triangle OAP is a right angle triangle, and in it we have the cos alpha. If you observe here, this one is the angle alpha. So this cos alpha will be nothing but the adjacent angle upon hypotenuse. And what are they? OA. What is OA? It will be simply the distance of point A from origin, that is nothing but x. We denote it as x. And this one is the hypotenuse. OP is the hypotenuse. And what is that hypotenuse OP here? This OP will be simply the vector r bar. So its magnitude will be nothing but r. So we can say cos alpha is x by r, right? So this r stands for the magnitude of vector r bar, that is distance OP simply. So in the same way, we can have the right angle triangles OBP and OCP, in which we can write as cos beta and cos gamma, so which are nothing but y by r and z by r. So in this way, the coordinates of the point P may also be expressed as LR, MR and NR. So the numbers LR, MR, NR proportional to the direction cosines are known as the direction ratios, right? What this L, M and N? This L, M, N, they are nothing but the cos alpha, cos beta and cos gamma respectively. As we have seen earlier, L, M, N, they are nothing but the notations for the direction cosines, right? So they are cos alpha, cos beta and cos gamma respectively. So that this x, y and z can be written, can be expressed as L into R, M into R and N into R, right? So they are so these numbers proportional to the direction cosines are nothing but the direction ratios of the vector r bar, and they are denoted as A, B and C respectively. Is this point clear for all? I hope it is clear. Now we also note that this L square plus M square plus N square is always equal to 1, but A square plus B square plus C square is never equal to 1 in general, right? So that will prove ahead wherever it is required, right? This ABC, they are nothing but the direction ratios. I repeat it, these numbers that we have the product of LR, MR and NR, right? To the direction cosines, they are proportional to the direction cosines and they are nothing but the direction ratios. Now we'll move ahead. We have some types of the vectors. Which are the types of vectors we have? The first one is a zero vector. They are very simple. Just the name itself will indicate what it could be. Zero vector will be simply a vector whose initial and terminal points coincide with each other is known as a zero vector. Means the vector with magnitude 0. Any vector with magnitude 0. Magnitude 0 means the displacement, the distance between initial and terminal point is 0. So that is nothing but, or simply a point which is denoted by two different points, two different names. So that is nothing but simply a zero vector. whose initial and terminal point coincide is the same points with two different names, that is nothing but a zero vector. So zero vector cannot be assigned a definite direction as it has zero magnitude, or alternately we can say it may be regarded as having any direction. The vectors a bar, the vector b bar, and so on represent the zero vector. Now the unit vector, a vector whose magnitude is unity, that is 1 unit. A vector having magnitude 1, that is the distance between initial and terminal point, if it is equal to 1 unit, it is known as a unit vector, right? The unit vector in the direction of a given vector a bar is denoted by a cap. See the difference between this a bar and a cap. So that shows the difference between the unit vector and a vector a bar. So the unit vector in the direction of the vector a bar is denoted as this a cap, right? So if you are asked to find the unit vector in the direction of given vector, it will be obtained in this way, and it is denoted by a cap, right? So let's move ahead. Co-initial vectors. What is the co-initial vector? The two vectors having the same initial point are known as the co-initial vectors. I hope it is clear. If you see the diagram here is given, you can see OA, OB and OC, they are the co-initial vectors because their initial point is same, right? So these vectors OA bar, OB bar, OC bar, or the vectors A bar, B bar, C bar are the co-initial vectors whose initial point is same, right? Two vectors or two or more vectors are said to be co-initial vectors having the same initial point, right? Now let's move ahead. The next type is known as a collinear vectors. Two or more vectors are said to be collinear if they are parallel to the same line irrespective of their magnitudes and directions. Two or more vectors are said to be collinear if they are parallel to the same line irrespective of their magnitude and direction, right? So any vectors which are parallel to some different, the third line. So suppose the vectors a bar and vector b bar are parallel to the vector c bar, then we say the vectors a bar and b bar are collinear vectors, right, irrespective of their magnitude and direction. So that is nothing but the collinear vector. Just like the collinear points, right, the collinear points will be they are along the same line. In the same way here collinear vectors will be two or more vectors which are parallel to the same line irrespective of their magnitude and direction. Now let's move ahead. The equal vectors. So the name itself indicates what it could be. The two vectors a bar and b bar are said to be equal if they have the same magnitude and direction regardless of the position of their initial points, and they are denoted as, that is the equality of two vectors a bar and b bar is denoted by a bar equal to b bar, right? Two vectors whose magnitude is same and magnitude as well as the direction is same, then it is known as the vectors are said to be the equal vectors. Now negative of a vector, it's also important concept. A vector whose magnitude is same as that of the given vector, say AB bar, but the direction is opposite to of that vector, that it is known as a negative of a given vector. Like if AB bar is a given vector and its direction is from A to B, then the vector BA bar, what it means? It means that B is its initial point and A is the terminal point. So its direction is from B to A, whereas the direction of vector AB bar is from vector A to that is it's from A to B. So A to B and B to A, they have opposite directions. So we can write the vector BA bar is opposite or negative of the vector AB bar. So hence we can say AB bar and BA bar are the negative vectors of each other, or simply BA bar is negative of vector AB bar, right? Also note that the vectors defined above are such that any of them may be subject to its parallel displacement without changing its magnitude and direction. So such vectors are known as the free vectors. Throughout this chapter we will be dealing with free vectors only. I repeat once again, the vectors defined above are such that any of them may be subject to its parallel displacement without changing its magnitude and direction. So they are in the same direction, right? So that is the condition here. So such vectors are said to be free vectors, right? So these are some important concepts we have discussed. They are simply the basic concept regarding to the concept of the vectors. So we have discussed all these things. So just revise it once again. So before going to solve the first exercise from this topic, you must go through it. Once these basic concepts are clear, then we can move ahead to solve the example. So in the next video, we are going to solve the example on the same concept.